Alright guys, let's start vodcast 5.4. We're going to talk about electron configurations, and this is really the heart of this whole unit. We talked before about structure of the atom and what's important in the protons, or what determine what an element is. But what determines an element chemistry is all about its electrons. So let's dive right in and start talking about this. We're going to talk about electron configurations, and what electron configurations are the most stable arrangement of the electrons. In other words, the way the electrons are usually is called the electron configuration. And we're going to start out today by filling orbitals up with electrons. Okay, and the way they fill up is in this little chart here. Now, we're going to talk about a couple of ways that you can know what this chart is without having to necessarily memorize it. We're also going to talk about a slightly easier way to memorize it. But this chart is sort of what you're going to fill everything in on. Now, do you need to copy this? Probably wouldn't hurt. We'll see, especially for today's lesson, we'll see that there's some other ways to get around that, but it probably wouldn't hurt at this point at least to just flat out copy this diagram. So if you need to hit pause to do that, do so. Okay, so rules for electron configuration. The first one is a rule called the Aufbau principle. And the Aufbau principle says that we always fill from the lowest energy level. Okay, so first off, let me just come over here to the side. When we write electrons, we write them in a couple of ways. Usually electrons are represented by arrows. In some books they're represented by circles, but typically they're represented by arrows. And after you write several of them, you start to get a little lazy. I usually write them as an arrow, sort of with a one-sided head. You'll see that we have up and down arrows, and we'll get a little bit more into that at the moment. Okay, so that's how we represent electrons. So the Aufbau principle says that if I have 3 electrons, okay, like say I was doing a lithium electron configuration, that I have to start filling them down here at the bottom. Okay, that I can't just arbitrarily start putting them up here, or start at the top and go down. You always start at the bottom and work your way up. Electrons fill up orbitals much like water fills up a bucket, meaning that you have to, when you pour it in, it all goes to the bottom, and then as you get more in there, it goes higher up. So that's the Aufbau principle. Okay. Second rule is called the Pauli exclusion principle, and it has this really, sort of long, actual definition. States that no two electrons in the same atom can have the same set of 4 quantum numbers. Well, we're not even going to really talk about what quantum numbers are per se. So what this means to us, okay, sort of the layman's definition is only 2 max electrons in each orbital. Okay, so we've got these boxes here in our diagram, and what the Pauli exclusion principle says is that you can only fit 2 electrons in a box. So if I was going to draw electrons here, I can only put 2 in the box. And this idea about the same set of 4 quantum numbers, again, we're not really going to talk that much about quantum numbers, hopefully not at all. But what that means is that they can't both be facing the same way. Okay, so like I can't. Okay, let me erase that real quick. I can't come in here to the box and put 2 electrons and they're going up. Okay, that doesn't work. And I also can't come in here and put, say, okay, 1, 2, 3 electrons in there. Okay, that doesn't work either. Okay, you can only fit 2 electrons in, and they both have to be facing in opposite directions. Okay, that's the Pauli exclusion principle. Alright, so far so good. The one that often throws kids off just a little bit is this one of Hund's rule. It states that orbitals of equal energy are each occupied by 1 electron before any orbital is occupied by a second electron. And you're like, oh, please tell me there's a layman's definition for this one. Okay, so here's the good news is, okay, the layman's definition is just this. All get 1 before any get 2. Okay, it's kind of, I like to think of it as the kindergarten rule. Okay, you don't, if there's not enough to share with everyone, then you don't get to have 2 servings. Or like if you're eating dinner at someone's house, you make sure that everyone gets some before you go back and get seconds. Okay, you don't get seconds before everyone gets served. You have to make sure everyone gets 1. Okay, so like let's take this 2p sublevel right here that has 3 orbitals, or 3 boxes. Each of these boxes represents an orbital. And let's say that I've got 4 electrons to fill that up. Okay, so I start putting them in. And ordinarily what we might do is say, okay, well, I know according to the other two rules I can only put 2 in each, and so I've got this blank one here. Okay, but that's not right. What Hund's rule says is correct then, is that instead of putting 2 in each and then having an empty one, that you have to go through and put 1 in each one first. Okay, and students always ask the question of, do you have to write the up arrows first? And the answer there is yes. You should always put the up arrows first and then go back and put in the down arrow. So now I have 4 electrons, but every box has at least 1. I don't have any empty boxes. That's sort of the big deal here, okay? So no empty boxes, if you can avoid it. Now, if you don't have enough electrons overall, then you're going to have some empty boxes. But if you can avoid having empty boxes, that's what you want to do. Okay, so the triangle method. This little diagram here is basically the way that you know what the boxes look like. Okay, so if we went back to our diagram here that I said, hey, you've got to sort of know this chart to be able to fill it in. This is how you know the chart. So you'll notice that everything in this column is an S, everything in this column is a P, D, and F. Okay, and you notice that it sort of forms a triangle. Okay, that's why it's called the triangle method, or more like a Dorito chip, the way I drew it. Okay, so that is the triangle method. So how does the triangle method then work? Well, if you can draw this out, like if you can memorize this little bit, and there's really no way around it other than to memorize this, except for using the periodic table, which we'll talk about here in a second. But if you memorize it, then it works like this. The triangle method goes like this, that you draw arrows up and to the left, and that tells you what order they go in. So I know that I go 1s, 2s, okay, 2p, and then 3s, okay, so 2p, 3s, okay, and so on and so forth. I know that the p's all have 3, the s's all have 1, the d's all have 5, and the f's all have 7, okay, and I would just keep drawing my chart here. So 3p, 2, 3, 4s, okay, and you're thinking, well, couldn't I just like know that it's like 1, 2, 3, 4? No, because you see, as we get up here into the higher ones here, we start to add this 3D in. 3D actually comes after 4s, and then 4p, and then 5s, and then back to 5d. And so it starts to get really complicated the higher up you go if you don't have the chart memorized. Okay. Now, I'm going to try to make it a little bit easier for you. If you don't want to memorize this, or if memorization is sort of your real weak point, okay, then you can alternatively use the periodic table to do much the same thing. Okay, so let's talk about how that works. So let's look at a periodic table. Okay, that chart basically gives us this diagram. Okay, that's what we're looking for. And actually, let me shrink this down just a tad because it looks like I got the 1s off the chart. Okay, and we need that 1s. That's where we start. Okay, so this is what we call orbital notation or longhand electron configuration. All right, whoa. I don't know what happened there. Okay, so this is orbital notation, longhand electron configuration. And, oops, okay, now I know what happened. Get crazy with the pen. Okay, and this is the normal way that the chart works. You can use the triangle method to get there, okay, or we could use the periodic table. So let's run through what the periodic table tells us real quick. Let's go back to some stuff that we learned in the last unit. Remember that these two columns are called the S block, that this area right here in the middle is called the D block, okay? That's the P block. And then down here at the very bottom, that this is the F block, okay? So, that being the case, we can simply follow along the periodic table to be able to get our electron configuration. So it's 1, okay, S, okay, so 1s, 1, 2, 2s, 1, 2, okay, jump across, we're still in the same row here, so 2p, 3s, 3p, and so far we're following along exactly with the triangle method, and you will the whole time, okay, 4s, and then we get here to D, and we would think that this should be 4d, but here's the deal, D's are always one below D's are always one below whatever the number over here is. So instead of this being 4D, 3D starts here, and down here is going to be 4D, and 5D, and 6D. Okay? And then what's helpful to remember is just that the F's on the bottom are always 4 and 5F. Okay? So just to keep going along the table here, so we got 4S, 3D, 4P, okay? 5S, 4D, okay? 5P, 6S, 5D. Now, when you get here to 5D, you got to jump down because remember there's a hole in the table, and this is a pullout that goes down here to the F. So once you get here, you got to jump down to the F. So it goes 6S, 4F. We're going to fill that in. And then we come back to 5D, okay, 6P, 7S, 5F, 6D, okay, and 7P. Now that covers everything that we discovered up till now. But what might be useful to you is if you just run through real quick a couple times and make sure that you know where you're at. And if you go to ptable.com, it makes it really easy because you can sort of check this stuff real quick. But like, so if I'm at phosphorus, say, okay, I know exactly where I end. I'm at 3, okay, I'm in the P block, and I'm 1, 2, 3 electrons over. So I'm at 3p3 right here. So I should end up, if I'm drawing my orbital notation, with 3 electrons left in P. Okay? So you say, that's all well and good, Arnold, but what does all this mean? Okay? So here's what it means. We're going to start out, I'll start out with a relatively simple one. We're going to do oxygen. Okay, I want you to do the orbital notation for oxygen. So here's how this works. You find oxygen on the periodic table. Okay, so this is oxygen right here. Okay, actually, okay, that's oxygen right there. And you find its atomic number. Oxygen's atomic number is 8. Remember, we said a week or so ago that atomic number is also the number of electrons. So the first thing you do is write down the element and write down how many electrons you've got. Okay? Once you know that, then you start filling in the boxes. Okay, alphabet principle says we start at the bottom. Okay, and Pauli exclusion principle says I can only fit 2 in the box. So 1, 2. So that's 2 electrons. 3, 4. Okay, we get up here, and remember these are all even levels. So that means I have to do Hund's rule. I have to give each of them 1 before I can go back and give any of them 2. So 5, 6, 7, and then I come back and put in 8. Okay? And then you stop and go back and check and make sure you have 8 actual electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 electrons. Wow, writing with a highlighter doesn't work well. Okay? So let's practice another one, and we'll obviously have lots of practice on this in class, but let's do another one together just so that we can make sure that we know how this all works. So let's do another sort of common thing. Let's do iron, okay, where it's a little bigger, but not too terribly complicated. So let's go back to our periodic table. Let's find iron. Okay, so Fe is iron. Has an atomic number of 26. Okay, so that means it has 26 electrons. So let's jump back over here. We write that down real quick. 26 electrons. Okay. And then we come down here and just start drawing them in. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, Hund's rule. 8, 9, 10. Okay, 11, 12, 13, 14, 15. Again, Hund's rule. 16, 17, 18, 19, 20. Okay, and then we're in 3D, so we should be at 21, 22, 23, 24, 25, okay, 26, okay. Now, here's a good way to check once you think you're at the end. So I ended up at 3D with 6 electrons in it. So I go back to the periodic table, I find iron, it is in 3D, so that's a good sign, and it's 1, 2, 3, 4, 5, 6 electrons over. So bingo, I hit my mark. Okay? Now, we'll talk about a few exceptions to this, and we'll talk about a way to shorten this up in a little bit, but that's the basic gist of doing electron configurations. We'll get a little practice doing this part, and this is called longhand.